am a sales engineer for HoSt Bioenergy. Welcome to our HoSt Halloween webinar. Get started here in just a moment. As you can see from the set and from my outfit, we are celebrating the Halloween season. We're big fans of celebrating, dressing up, and all the fun things, because why not? So we'll go ahead and get started. I've got some quick icebreakers for everybody. Some jokes. I came up with these, so you can judge the quality yourself. What do you call an anaerobic tank full of undead microbes? Give you a second here. This one's pretty easy. The answer is right there. It's a digester. Easy. Okay. Why do skeletons make for a terrible feedstock? Don't overthink it. It's because they're all bones, no volatile solids. What is a zombie's favorite output of anaerobic digestion? Think about it, think about it. You're not going to guess. It's methane dedicated to the LCFS market. That one's bad. That one's really bad. I like this one. What do you call a digester full of pumpkins? Obviously, it's a gorgeous digester. So, as you may have guessed, and as we teased in the run-up to this webinar, you're going to learn 3 things during this webinar. It's all in fun. It's all in a Halloween spirit. But in this webinar, you're going to learn about the HoSt bioenergy process, meaning we take inputs from our customers, feedstock data, and we plug them into our biogas modeler. Internally, we call it our biogas system configurator. So we're going to walk through that process. Secondly, we're going to explore and learn about the expansive HoSt feedstock database. And then lastly, we're going to go through some equipment selection, our solid feeder system in particular. But first, how did we come to this webinar? What was the inspiration? Well, a couple weeks ago, we were doing a team building activity in the office, painting pumpkins. You'll see my pumpkin on the right, and it's here on set with me as well. And while doing this pumpkin painting, well, we're a digester company, and somebody asked, how many pumpkins end up in landfills after the holidays? So think about it for a sec. I mean, the entire United States. Well, it's a lot. It's about 1.3 billion pounds. So naturally, we started thinking, what if we put these pumpkins in a HoSt biogas plant? How much biogas, RNG, and liquid CO2 could we generate? If only we knew somebody who could do this for us. Well, you do know somebody. That somebody is me, Jorgen Gilbertson, sales engineer for HoSt Bioenergy. I've been in this position since 2022, and this is what I do for HoSt. I build the modeling and the pricing and equipment selection during the sales process. So let's jump right in. We have our project premise of 1.3 billion pounds of pumpkins going into the digesters. And then this is a kind of a screenshot of part of our biogas modeler. Just real quick, everybody, we understand that this is not a realistic project because all the pumpkins come, it's from all over the United States. And then secondly, they all come in one season. And so this is taking all of these pumpkins, imagining that they are in one central location and that they come throughout the year. Obviously, this is not realistic. We understand that. This is just a model to show what is our process and what would a project like this look like. So a pumpkin, we have this in our database. We estimate for this model, we assume a total solids of 14%. The volatile solids of the total solids is really high at 92.3%. And then this BMP figure. For those of you who don't know, BMP stands for biomethane potential. And what this is saying that for each kilogram of volatile solids, aka organic matter, that is the organic matter is the matter that has the potential to become biogas. So for every kilogram of organic matter that enters the digester, how many cubic meters of methane would be produced. And this is a lab tested number, and we have it at 0.422. It's right in the middle. Manure would be lower, and food waste and fatty things would be higher. But as we'll find out, pumpkin is actually a very good feedstock. Lastly, we have another input of the CH4 percentage of the biogas. What percentage of the biogas would be methane? So that is our project inputs. And remember, it's all about the volatile solids. The volatile solids are the only things that have the potential to become biogas, or in the words of Dracula, I want your volatile solids. Next, in the process, we've put in our inputs. So now we step to our digester selection. This is where we are modeling a digital biogas plant. How many digesters? We check the retention time, the organic loading rate, lots of different criteria. For this webinar, I'm going to keep it pretty high level, and we're going to breeze through a lot of this, but feel free to engage us to go a lot deeper into some of these different metrics. So for this digester system, we would require 4 primary digesters, size 131 feet in diameter by 32 feet in height. And then we have half that number of digesters as our secondary digesters. So that means we are feeding the 4 primary digesters in parallel, and then the secondary digesters are in series. The total retention times comes to 44 days, so 28 days in the primary and 15 days in the secondary. It actually averages with decimals and everything to 44 days total. Now, this is a really important point here. Conversion rate of VS. Remember, VS is volatile solids. And on a typical biogas plant, your typical technology provider out there, they're going to have conversion rates of 70 to 80%, meaning of all the volatile solids that enter the anaerobic digestion process, what percentage of those volatile solids are actually converted to biogas? Again, most technology providers only do primary digestion. They don't do secondary digestion. And with our secondary digestion, we're seeing a conversion rate of 95.5%. That's industry leading, and that is really something that's important to us at HoSt Bioenergy. So next we have a quick word from our CEO, Robert Lems. He's going to tell you a little bit about HoSt as a company, and then also talk about our feedstock database.
Hi, and welcome to HoSt Bioenergy North America. We're here in our Vancouver, Washington State head office. My name is Robert Lems, and I'm the CEO, and I want to give you a small tour. For the last 5 years, we've building up our presence in the US. We have more than 35 upgrading systems and already 8 digester systems producing biogas from different kind of feedstocks. At the same time, we have also building up our team of US employees, and we have now over 30 people here present in the US. We have everybody from project managers, engineers, to service people in the field. For each of these states, we have local service engineers doing the maintenance and the service of these plants, making sure we have the highest uptime in the field. With over 35 years of experience, we are the #1 technology provider from organic waste to energy. We have a full in-house portfolio of technologies that turn organics into useful energy. Like you see here, we have anything to do with a digester, feedstock handling, and turning the organics into biogas. But from there, we can either upgrade the biogas to RNG, utilized in the industry, utilized in your kitchen, but we can also utilize the CO2. We do purification of CO2 to food-grade liquefaction, used in greenhouses or used, for example, in more futuristic technologies where we can make e-methanol. Here you can see that everything in the industry is tied together, so it's a full circle of technologies using HoSt or Bright technology. So how did we become the #1 technology provider for waste to energy? This was not an overnight success. We're already a second-generation family-owned business that has over 35 years of experience. We have done projects all over the world and have over 100 references. We have used any kind of feedstock either in lab testing or full-scale testing. Our database with biomass potential is the biggest in the world, and we can show you for any kind of feedstock or feedstock mix what is your biogas production. So if you come to us, we will make sure your project will be a success. If you're working with a feedstock that has ever been tested in a digester, most likely HoSt Bioenergy has tested it and has experience with it. Just to give you an example of all the feedstocks that are in our database, you can see here solid manure, liquid manure, chicken manure, slaughterhouse waste, but also straw manure, straw, banana potatoes, corn silage and corn stover, distillery grains, sugar beets, vegetable waste, onions, and packaged food, egg waste, nuts, cookies, and of course, to keep in the season, pumpkins. So if you think organics, think HoSt Bioenergy.
Thank you, Robert. So we've built the model with the inputs of pumpkins per year. We have set the number of digesters. Now it's time to see the outputs. How much biogas, RNG, and CO2 would our pumpkin project make? Let's find out. Okay, this is the big number here. Biogas, 4,185 SCFM, and then these two are the money makers. This is what you're able to sell. 1.151 million MMBTU per year of RNG and 58,000 US tons per year of CO2. Really strong production out of pumpkins, of all things. So I know my audience, our customers are developers, and they're going to say, what is the revenue? How does this make us money? And this is what it's all about at the end of the day. Now, don't come with your pitchforks at me. I'm a sales engineer for a technology company. We're going to make some assumptions about our revenue model here, but just entertain us here. So based on $20 per MMBTU of RNG, that would equate to $23 million per year in RNG sales. And at $100 per US ton of for the CO2, we would see about $5.8 million per year in revenue of CO2. And CO2 is very regional, but we know of many different regional markets that are $100 per US ton or more for the CO2. So that totals nearly $29 million per year in revenue. So like I said, a very good project, which is something to get excited about. Okay, so now we've modeled, we put in our inputs, we have our outputs, we have our general digester design. Now is where I step in as a sales engineer and I start looking at equipment to then support this process. We are going to focus today on the solid feeding system, which comprises of 3 subcomponents. Now note there are many other components that we would have to select, such as the heating system, our H2S reduction, that would also be part of the process. For today, we're going to keep it high level and just look at and highlight the HoSt solid feeding system. So again, the solid feeding system comprises of 3 subcomponents: the solid feeder, an optional hammer mill, which I'll get into in a second, and then the blend unit. The solid feeder receives solid feedstock. The hammer mill blends it up or shreds it if necessary. And then the blend unit takes this solid substrate feedstock, mixes it with a liquid fraction, either dilution water or digestate from inside of the digester, and creates a pumpable mixture that then can be pumped into the digesters. This is important for a few reasons, which we'll get into in a second. But lastly, I wanted to note, this is an output of our biogas system configurator, as we can choose the size of solid feeders, the number, the density of the material, and it gives us not only a storage time inside the solid feeders, but then also the amount of time that the pumps would need to pump. So it's a very powerful tool. So first we look at the solid feeders. What is a solid feeder? The solid feeder is this large rectangular receiving bin. And so material gets put into the solid feeder, whether that's via a front loader, or it could be buried in the ground and have trucks directly dispense into the solid feeder. So this is a very valuable cutaway. It shows physically what's going on inside the solid feeder. These push the material toward the feeding augers. There's 3 different types of augers that each have their own function, but this last auger takes the material and the solid material and pushes it toward our second process, either the hammer mill or the blend unit, depending on the project. Next, we talk about the hammer mill. What is the hammer mill? The hammer mill takes the solid feedstock and shreds it up. It breaks it down. This is important for 3 reasons. One, it makes it so we can, in the next step, pump the feedstock into the digesters, which is handy for feedstock handling. Secondly, it avoids clumping and floating layers inside the digesters when we shred it up like this and pump it into the liquid layers. And then lastly, because you're creating more surface area, you're shredding apart the organic material, it actually creates more surface area for the bacteria to begin digesting it. And so it will produce more gas when you put it through a hammer mill. So here's a hammer mill. This piece of equipment here is the hammer mill. You can see on the right, this is the solid feeder. So the material gets fed via auger and then comes up here and drops the material, the solid material, down in through the hammer mill. If we were to open this door here, this is what we're looking at inside of the hammer mill. So this first plate here, this is a powerful magnet. As you can see, this magnet has picked up 2 pieces of metal shown here. It's important to keep metal bits out of the solid feeding system, but contaminants are going to happen. And then this it rotates at a very high speed via this 90 kilowatt motor or 100 horsepower motor and just shreds everything that comes into it. Lastly, we have the blend unit. So if we look here on the right, you can see the solid feeder. The material gets augered up to the top, drops through the solid feeder shreds everything up, and then this unit here is a blend unit. And we've used many different types of blend units. Here you can see this is a different brand blend unit, but the material is augered in here and then mixed with liquid fraction. So this is the liquid feed line, mixed with liquid fraction, and then pumped into the digesters. So here's a video where we see all of it in action. This is a 240 cubic meter solid feeder system. So there's a reception bin here and a reception bin here, and they're bolted together. And so these actually feed from the middle. So all of the material will be worked toward the middle. In this particular case, what's being dumped is straw manure. It's cow manure, horse manure, and just about every type of manure that they can get their hands on with a lot of straw mixed in. So now we're going to take a look inside of the hammer mill, or rather the output of the hammer mill. You can see the material after it's been shredded. It's dropping out of the hammer mill and then being augered into the blend unit. So you can see it's still solid. It's been shredded, but it's still solid. So that shredded but solid material will be mixed with liquid fraction and pumped into the digesters. This is a look inside of the solid feeder system. You can see there's these slow rotating augers. And then here it is, this is the blend unit. You can see it's a dry material, just been shredded from the hammer mill. So we looked just at our solid feeders, which are represented here. And so this is a realistic layout for this proposed project. We have 4 primary digesters, which would be these 4 here, and 2 secondary digesters, these 2 here. So in reality, these 2 primary digesters would feed this secondary digester, and these 2 primary digesters would feed this secondary digester. It's in series, so it's a 2-to-1 ratio. And this is a very realistic size project for us. In fact, we are constructing this very layout with these size tanks and these mixers and everything for a project in the Pacific Northwest currently. You can also see this would be the layout for the upgrader, and then this is the CO2 liquefier with 4 CO2 liquefier tanks. Also, a lot of our other equipment is containerized. You can see some pump skids here. So if we continue on this path, which goes beyond this webinar, we select all the different heating system and a lot of other subcomponents as well. But this is a good general look at a standardized layout that we have for this very type of project. So what did we learn during this webinar? We learned about the HoSt bioenergy process, how to take inputs, select your digesters, and model the outputs. We touched on the expansive HoSt feedstock database, which we believe is second to none in the world. We've had our own laboratory, and we've been testing various feedstocks for decades, and we have over 100 operational biogas projects worldwide. So if there is a feedstock that has been in a digester, very likely we have experience with it. Lastly, we looked at the equipment selection and that process, and specifically touched on the solid feeder system, which would be required for the pumpkins. The pumpkins would need to be shredded in the hammer mill and then pumped into the digester. And as a last thing, we learned that pumpkins are not only a fun seasonal gourd, but an excellent feedstock. So what is the main takeaway? When you think organics digestion, think HoSt bioenergy. Thank you very much. This concludes the webinar. I hope you got some good information out of it. But most importantly, when you have some questions about a biogas project, please reach out to me or my counterpart, Nina Wolfhart, and we'll be happy to help you. Thanks for coming. Have a wonderful day.